Hello, and welcome back to my series of tutorial videos on Panda3D game design. Today, by popular demand, I will be going over complex PBR version 059 usage. And due to the depth, the complexity, and the flexibility of this rendering module, which I authored to support real-time reflections and post-processing effects in Panda3D, I would like to just go over the minimal usage and then show, practically speaking, how version 059 can be used in the updated Panda3D Arena FPS sample program. Now, the minimal usage we see here is actually technically not the smallest instantiation of complex PBR, as we're using the showbase inheritance convention into our main class here. All we really need to do at this point is call apply shader on base.render. Or in this case, we can call it self.render due to the inheritance of showbase. What this looks like in the slightly updated Arena program is the following. And I will just quickly note a couple new changes. For one, arena.py, which is the start point, is now called main.py for clarity. And we can see the effect of the new global illumination approximation strategy, shadow boost shader input parameter, which in this case on the wood sphere is set at 0.5. And on the metallic sphere it is set to the default, which is 0. So we can see essentially just the skybox and environment dynamic IBL contributions on the metallic object. So in terms of our setup inside of the main.py file, it's pretty simple. We're just calling apply shader and specifying a custom directory for the shaders, which is right here. And I will note that the custom directory feature does work, including with shader files generated by append shader, but for distributable builds, I highly recommend including the IBLF, IBLV, and the screen space shaders in the top level directory. Then when the executable in the distributable build runs, it will generate shader files into your custom directory while sampling the top level shader files as part of its core program. The new shadow boost global illumination input is set this way. For the player's gun in this new Arena program, we're setting it fairly low at 0.1. And for the spheres, we're doing this sampling heuristic, which determines which spheres we want to apply a shadow boost of 0.5 on, which is significantly higher than on the player's gun. In terms of other complex PBR inputs and features, I'll go ahead and just mention a couple main ones. Hardware skinning is set in this way, complexpbr.skin, and this is your actor model. And we have our actor stored in this conventional actor data.py, but what's happening is essentially just an actor loaded with direct.actor.actor and being skinned after being imported from our actor data file. The screen space effects, such as modifying SSAO or bloom, are well documented in the readme.md file in the GitHub repository. In this particular case, we're setting the following shader inputs to modify our screen space effect values: bloom intensity, is an important one, and my implementation of Bloom is admittedly fairly archaic. However, I personally like the effects of this particular Bloom implementation more than a more modern approach, as I'm weird like that. It is a fine strategy, though. Here I've just turned on quality mode, which turns on the screen space effects with the settings that we have in here. And we can see the highlights there being kind of bloomed and blown out. The clouds show the highlighting as well. And the image, of course, is just a little bit softer due to the anti-aliasing and other effects. SSAO is set to 6, and our color adjustment has a green contribution just a little bit higher than red and blue, which gives it a slightly green-tinged appearance. And perhaps finally, for today's usage tutorial, I'd like to demonstrate what building an executable version of this program with complexpbr might look like. This is what you would be hypothetically selling or giving to an end user of your game or other program. Just go ahead and find the executable in here, which will be called FPS program, and verify that it launches. And yay, it does. And it looks like the screen space effects are working. And it looks like complexpbr is working as expected. Now, I don't really have time to do a proper tutorial on a pen shader, which is, of course, new functionality and fairly exciting functionality, which allows modification of both the fragment and the vertex shaders at a node level with complexpbr, and giving it strings with your shader modifications. This allows programmers who might not want to or might not know how to write an entire fragment or vertex shader file and want to leverage the existing base program that is complexpbr. But like I said, I'll have to leave that for another tutorial video.